The next slide is on sign convention. It is absolutely nothing more than convention. Someone picked these signs and said, this is what we're going to use. You may, and almost definitely will, find them in the opposite kind of order somewhere online if you're looking for other resources. I just need you to memorize the convention we use for our class. Okay? And you will be penalized if I say, oh, hey, was that work positive or negative work? And you get it backwards, you're going to have to take some small penalty because I asked you to memorize what we're doing here. Okay? Here's the sign convention that we're using. Work that is done on the system or heat that is transferred into the system is positive. Okay? And so we're going to look at our example we're going to look at for the rest of today, and much of chapter 6 is this oversimplified gas in a cylinder with a piston on top. Okay? And like I said, it's kind of our simplified case before we talk about more complicated stuff. And so work done on the system. If the system is the gas inside that piston, if I push down on the piston and I compress the gas inside, I'm doing work on it. That's positive work. Compression is positive work. Okay? And if I put heat into the system, I take my whole piston and I put it in a water bath that's hot, and heat starts flowing in, positive. Okay? Whereas work done by the system, okay? So if there's some chemical reaction that we're going from a solid to a gas and it needs to expand and it pushes against the piston and expands the piston out, expansion work is negative work. Okay? Work done by the system on the surroundings is negative, and heat transferred from the system, so heat flowing out of a system, would be negative. And so because we have this equation here, we can think any positive terms, so compression work or heat flowing in would raise U, heat flowing out or expansion work would lower internal energy. Okay? Think about how the signs of those two terms, heat and work, contribute to internal energy. And so this is the example here. I have just some gas. I have some constant external pressure. I'm at atmospheric pressure, just holding the piston down. And as I put work in, the gas heats up. It wants to expand. And when it expands against this piston, it's negative work done by the system. That's why this negative sign is here. Heat's flowing in. It's positive change in heat. There's some positive change in volume. Volume's getting bigger. P external is not changing. We're at constant pressure, some constant external pressure. And it's negative work. Okay. This figure is from your textbook. Both of these are. This piece here, which is correct, and then this piece which is not. There's a negative sign missing. So just be aware of that.